Hey there, Chloe. What are you doing?
Hey Madison, I'm just learning about liquid nitrogen and the effects it has on an ordinary balloon. I have to deliver a presentation to Year 9 students at a school next week.
That sounds interesting. What is it exactly that you're teaching the students about?
I'm teaching them about how the particles inside a balloon change state when the balloon is placed inside a liquid nitrogen canister.
Liquid nitrogen? What's that?
Liquid nitrogen is nitrogen that is cold enough to exist in a liquid form. It normally exists between negative 196 degrees Celsius and negative 210 degrees. Below negative 210 degrees, nitrogen freezes and becomes a solid. Above negative 196 degrees, nitrogen boils and becomes a gas.
Whoa, that's really cold.
Yes, it is really cold. Put on your safety goggles and those protective gloves. Instead of me telling you, how about I show you what happens when a balloon is placed in liquid nitrogen and the physical changes that occur. When you blow up a balloon, you are filling it with gas from your lungs that is at room temperature and pressure. Inside the balloon are gas molecules. These gas molecules move quickly. They hit the sides of the balloon like little punching bags, pushing out the walls of the balloon, exerting pressure. Because of this, the balloon stays in a nice round shape.
Oh, so a balloon remains inflated because of the gas from inside our lungs bounces around inside the balloon, hitting the sides and therefore keeps it inflated.
Exactly, Madison. So, when we first expand the balloon, it is at room temperature, which is obviously much warmer than the temperature of liquid nitrogen. When two objects of different temperatures are put in contact with one another, there is an exchange of thermal energy. This is known as heat conduction, which causes the warmer object to cool and the cooler object to warm. Do you remember what the temperature of liquid nitrogen was, Madison?
Wasn't it about negative 200 degrees Celsius?
Close, negative 210 degrees Celsius. So what do you think will happen when I place this balloon into the liquid nitrogen?
It has to pop. Surely it cannot remain intact in those extreme temperatures.
Let's find out. So what happens is, when the balloon is placed in the liquid nitrogen, it immediately begins to change its physical state because of the extreme temperature change from outside the canister to inside the canister. By placing the balloon within the canister, it makes the air in the balloon become colder. It forces the molecules in the air to slow down so they become less pressure on the balloon. Because there is less pressure in the balloon shrinks. By making the liquid nitrogen in the air cold enough, it turns into a liquid. Soon enough, the cold air in the balloon becomes a liquid too, and you can see this in the bottom of the balloon. The liquid nitrogen within the canister begins to bounce and vibrate against the balloon. This causes the liquid nitrogen that was originally a liquid to begin to change into a gas and evaporate. The balloon within seconds changes totally into a liquid and therefore shrivels up inside the container.
Oh, so it doesn't explode. Why is that, Chloe? How could that be? I would have thought for sure that it would pop. So if the canister was half full with liquid nitrogen, why is it that when the balloon is placed inside it, the liquid nitrogen does not overflow and freeze the table?
Good question, Madison. What happens is that when the balloon is entered into the liquid nitrogen begins to change form into a gas as it bounces off the balloon. Therefore, the overflowing matter does not remain as a liquid and is therefore a gas overflowing out into the atmosphere. As it is a gas, it does not freeze the table because the gas remains in its final form and evaporates into the atmosphere.
So would this mean when you take the balloon out of the liquid nitrogen remaining in the canister that was forming into a gas returns to its original negative 210 degree temperature and forms back into a liquid state?
That's right. I like the way you understand the reverse change of this. So what do you think will happen to the balloon?
When you remove the balloon from the liquid nitrogen canister, it will originally be shriveled with liquid in it. However, when the balloon begins to warm up and adapt to room temperature outside the liquid nitrogen canister, the liquid inside the balloon will begin to vibrate and bounce off the edges of the balloon's perimeter, causing it to expand to the original size, temperature and pressure.
That's right, Madison. Good work.
Wow, Chloe, that made so much sense to me. The way you explained it on the diagram was clear and concise. You're going to nail that presentation. Thanks for listening to our presentation on liquid nitrogen and the effect it has on an ordinary balloon.